Okay, okay, myself, let me introduce as myself Ishwaraj B. Patil, professor, assistant professor here, okay, in the CSC department, okay. I'll be handling here the one subject that's the BCS 302, okay, it's nothing but the DDCO, okay, I'll be handling this one, okay. So I have the, uh, I have taken this subject one last year one time and also even in the earlier colleges also I have taken, okay. I have the 6+ years of experience in teaching and the 4+ years of experience in the software engineer. Okay, as a software developer, okay, as a software developer, I work as a 4+ years of experience. Okay, and even I am a social worker and I am very interested in the passionate about the teaching. Okay, even okay, the subject is here the combination of the two subjects here. One is what a digital design and another one is what computer organization. Okay, digital design and computer organization. Okay, computer organization. Okay, digital design is one of the subject. We have the in this we have the two models, one, two, and here we have the three models, three, four, and five. These two models are related to the digital design, completely digital design. First one will be here we will be studying the completely the basics of the logic gates. Okay, how the logic gates have been defining here. What's the combination? Okay, we'll see the some simplification of these logical gates and also some K-map and all. Okay, K-map all. Okay, in the second module we'll be seeing the combinational logic circuits. Okay, with the sequential logic circuits. Okay, there are two types here: the combinational logic circuits and even sequential logic circuits also. But here the in the computer organization will be we have the three models here. These are the related to completely CO. That's nothing but the computer related. Okay, how the these logic circuits? Okay, logic circuits have been implemented in the our computer. Okay, we will be implementing the whatever we will be studying the combination logic circuits and sequential logic circuits and also basic logic circuits. These circuits how to be implemented in our computer. Okay, that will be organized, how to be organized. We will be seeing these things. Okay, okay, this is the main. Okay, this is also one of the core subject for this is one of the easy subject actually, electronics related subject. But here the why they have introduced for you means what is sometimes you need to work in the electronics related companies also. Okay, completely the work is your CS students have to be work in the sometimes with the electronics related companies and also there you have to be work. Okay, how the our digital circuits are been working here. Okay, you should have to know this one. Okay, that's what they introduced this one. So many electronics related subjects for your CS subject means in the third semester, fourth semester, fifth semester, and also sixth semester. One or two subjects are there related to the electronics. Apart from the you should have to you need compulsory you should have to study the these electronic subjects also. Okay, this is one of the easiest subject if you knew the logics. Okay, if you knew the logics. Okay, because digital design is completely depends on only logics. Okay, many of the students are not able to even tell the some basics also after the completion of their this course of the digital design and computer organization. So that I'm insisting you to from the day first class you should have to attend the classes regularly because the we will be discussing only the basics. Okay, these basics only I'll be using here. That's the main problem. That's the main thing here. The students will not attend these basic classes. They will start blaming us. Okay, that should not happen with us also. Please attend the regularly classes to the even digital design and also computer organizations classes. Okay. Hmm? Okay, before proceeding to the class, let me have some introduction about you also. Okay, I would like to know you. What's your name and your village, your native? Kalburg. You are from Kalburg. Your name? Huh? Radhik. Your name? Ankita. Arpita. Okay. Okay, I know you. Okay. Okay, only two students are there, but I'll be continuing the classes with the subjects. Okay. What is the necessity of the studying the first chapter is here the um, digital design. Okay, we let us to consider to the module one. Module one we have the some from some will be here will be studying the logic gates, and also we'll be studying the simplification of these logic gates with the why okay, so with the for which are implemented in the some equations, some functions. Okay, these functions have to be simplification. Okay, this is to be only for the three variables. This is to be only three variables. If I have the more than three variables, then I can't simplify these boolean functions with the three variables. I should have to, this kind of postulates and theorems related to the our logic design. But I would have to switch to the K map. K map, Carnot map, okay? K map can implement, simplify the Boolean functions up to the 6 variables also. More than 6 variables, we can't simplify in even K map also. Then we'll go for the some alternate techniques, okay? Then alternate techniques. But here the for your syllabus, we have the 4 variables K map only. 4 variables came up only. And also we'll be studying here the with the some POS SOP means what? Sum of products, and also POS means product of sum also. Okay, some canonical form and also non-canonical form also we'll be studying here. Okay, this is all about the first module. Okay, first module. Okay, this is the many. This is very basic classes we'll be seeing here. Okay, for this you need to know the some basic classes from the previous. Okay, your engineering first semester engineering. Okay, there you would have know that what is a truth table, what is logic gates. You should have to know some basics of this class. Okay, I would not teach each and everything here, but I'll be handling this. I'll be taking the classes on the logic gates with the very simple way, and also will be moreover I will be concentrating on the K map. Okay, simplification of the gates and also SOP and POS forms. Okay, okay. Let us to consider first one as the logic gates. Okay, what is the necessity of the logic gates? We'll be seeing. Okay, definitions of logic gates. What is the logic gate means what? Being, okay, binary forms. Okay, we will be using the, okay, as in the world. Okay, we have the two things here. Okay, either of yes or no, yes or no, either a true or false, either it may be head or tail. If I tilde any coin, I have the two options here, either head or tail, yes or no, or true or false, or high or low. Okay, these are the two combinations. Okay, that's what they given the name as the by. By means what here? Only the two things you can. By means what? Two. Okay. Here the by means what? Here the two options here would be here the true or false, or on or off, or higher, low, yes or no, and also even in the distal. Okay, if I consider to the numbers, I'll be having the what here the 1 or 0, 1 or 0. Yeah, okay, we are dealing with the completely our digital design, we are dealing with only the 1 or 0, 1 or 0. Why the name given as the binary means what? We have the only any variable. Okay, any variable have the two options. Okay, what is that? You can have say that the true or false. Okay, even you can also head or tail, lie or die. Okay, if you have any, okay, almost all in the world we have the only two options. Okay, either you can live or die. Okay, even as head or tail, or else true or false, on or off, high or low. Okay, yes or no, 1 or 0, whatever it may be. If you consider any variable, okay, ಇದು ಸರಿ ಇದೆನಾ ಸರಿ, okay, ಕೆಟ್ಟಿದೆ ಕೆಟ್ಟು. Only two options we have. That's what they given the name as the binary. Okay, we are dealing with always with the binary things. Okay, in the digital design completely we are depending on the, we'll be dealing with the 1 or 0. For every variable we consider it will have the two values, 1 or 0, 1 or 0. Okay, that's what they given the name binary. Okay, what is the logic? Okay, what's the logic? Okay, logic means what here? The some operations we are performing on that particular variables. Okay, if I have the variables means what? I have to perform some operations with the help of the variables. Okay, those variables. Okay, those operations called the logic. Some operations could be here the related to my digital design or the or and not. Okay, and also variables can have the names as what here the variables. Okay, whatever the variables I need here, Variables can be named, have the name as the any name as the alphabets as the X, Y, Z, whatever it may be, A, B, C, like this. Okay, in alphabetical. Okay, if you variables are represented with the help of the name of the alphabets only. Alphabets. Okay, if I have the variable X, it can have the two values, either 0 or 1. It can be if you have the variable has the A, that can have the two values, as the 0 or 1. Okay. Yes, ma'am. Okay, many values. But thing is that it can have the only two options here. Okay, 0 or 1. Variable can have the many variable can have the many values, but thing is that it have the only two options, either 0 or 1. Okay, 0 or 1 combinations can have the so many values also. Okay, 0 0 0 1 1 0 1 1. And if I have the three variable combination, then I would have the some values related to the with the decimal value numbers as 0 to 9. Okay, sorry, 0 to 7. Okay, 0 0 0 0 0 1 1 0 0 1 0 0 0 1. We'll discuss those things. Okay, with the related to the decimal numbers. So okay, I'm concentrating on only one variable here. I have not taken the combinations of variables. If I take the combinations of these two, then I would have the four variables, four combinations. If I consider to be three variables with the one group, then one term, then these three variables can have the around 2 to 3 means 8 combinations. If I have the 4 variables with the card in the one single term, then I would have the there also 16 combinations. Okay, just I'm concentrating only one variable can have the only 2:1. This is nothing but the 2:1 is nothing but the only two options. Okay, these variables can have the combinations with the help of the 2:n. If I have the only one variable, then definitely I would have the only two options here, two values here. If I have the two variables, if I have the only one variable x, okay. If I have the two variables x, y means what here the 2:2 is nothing but the four combination of values. Like this, we'll have the so many things. Okay. If I have the 2:3 three variables, then would have the three variables with the 8 combinations. Okay. Similarly, with the 4, it will be have the 16. Combinations also. Okay, but I'm not concentrating these things. We'll discuss the coming classes. But I'm telling you where the one variable can have the two values, either 0 or 1, either 0 or 1. Okay. Okay, one more thing I guess I not told you that this gate. What is the gate? Why they have given the name as the gate? Okay, gate means what? Why they have given the gate? Instead of gate, you can give the any name, no? But gate is nothing but the, as you already in general, okay, in general, gate will allows the only the things which are to be enter to the particular area. But thing is that similarly, the gate is also allows only for the things which are to be for true. Okay, it will be allow the only the one. Okay, if it is not, if it is a 0, then it would not allow to the result as the completely as the 0. Means what here the your gate is working as the simply something, okay, which is to be barrier, which is to be considered to be sometimes happen working as the some what soldier, like a soldier. Means what here the gate is the nothing but the it's completely it's preferring, okay, the result which is to be displayed to the viewer. Okay, that is to be given by decided by whom, that particular hardware. That hardware we call as the gate. Okay, as you all know that Tungabhadra Dam, okay, dam. There also we have the so many gates. If it allows the opens, then it will be water will flow. Water will flow. That's nothing but the if it's open, water will flow. Otherwise, it's closed. It will not allow the any water. Like this, we have the if the my switches. Okay, this is that's what I given the name has the gate. Okay, logic gates. With logic gates, if the some operations I perform there, any AND operations, OR operations, NOT operations, then the result would be this would be sent to the output. Okay, as a output that is to be done whom the gate. Okay, that the given the operation, that's the given the name as the gate. Okay, I hope you all following this one. Okay, why the name as the by came logic, variables, and gate. Is it clear? Okay, then I would move. Okay, shall I move to the next part? Okay. We all are the in the era of what is here the digital era. Okay, in the age of what here the digital age, each and every, okay, the our country, our the world completely wants to be our area to be completely to be digitized. Okay, digitized. That's what we are coming to the every time in the each and every practical and even some devices completely we want to implement those things with the digital in the digital main area. Okay, this all completely this type of digital techniques are used in the what here the in the medical field, even in the medical in the traffic okay, everywhere. Okay, we will be using this, even mobiles, even everywhere will be using the this completely digitized only digitized. If you want to process any image, there also I need the digital image processing. Okay, digital image processing. If the image is on, if image is a dark, that means here the it is to be get taken to be 1. If its image is off, means white, there to be considered as the 0. It's like this, we need everywhere will be considered using the this completely digital design. That's what the given is the name Logic Gates. Okay, that's the digital design completely each and every field will be using. Okay, okay. Binary operations. Okay, that could be here the variables. Okay, and also okay. Then I have already told that there are three operations, main operations here: and, or, and not. Okay, that's what we will discuss. Okay, logic gates. Here the main three logic gates are there. Okay, operations with the we will performing the dealing with the digital operations. Okay, some operations we are performing here the with the related to the with the help of the variables. Okay, those are all operations are here what here the and, or, and also not. Okay, not. Okay, if I go with the and operation, it will perform only the what here the combination of the okay, you variables can be a number of variables. If I use the two variables, then I would consider to the be and. Okay, that's the and is represented with the help of the this gate. Okay, this gate symbol representation of the this and is to be referred to be with the help of what here the graphical representation. This to be here the what here the a B, and also it's a Z only. It's Z only. Okay. Here the is to be here the we are performing. Okay. If the variables is having the both the variables are 1, then only the output is 1. If the both variables, okay, A and B are where high, then only the output is what here the high. Otherwise, it's low. Okay, it's low. It's the mainly thing here. The I have the one truth table related to this one also. Okay. I have the A, B, and Z. Okay. Before to enter to the truth table, so that I will this and operations are represented with the what here the some operator here. That's nothing but the dot operator. Okay. Dot operator. If I want to implement this and operations, A dot B, A dot B, A dot B. Okay, A dot B is equals to the Z equals to A dot B. Means what here the this logical operation. Okay, this logical operation is nothing but the and operation that is to be implemented with the help of what here the operator that we call as the product form, or else we can say is the dot operator. Okay, dot operator. This okay. This dot operator works as this like a multiplication. In the general way we say the multiplication as a multiplication. If I have the two variables, both the variables are high, then only the my output is high. Otherwise it is to be low, 0. Okay, 0 or low. Okay, if I taken the two variables, I have already told you that 2 is to 2 means what 4 combination I would have here. Okay, yes or no? Yes sir. 0 0. Okay, then the 0 1 1 0 1 1. Yes. Okay, I know, I hope you all have this basic idea. Okay, why I have taken these combinations means what, if I have the two variables, then I would have the definitely I have the only 4 combinations. Okay, that's nothing but the 0 0 0 1 1 0 1 1. Then there's the product form, that's nothing but the dot operations I am using here. Dot operations I am using here. So it's nothing but here the dot operations means what here the it's doing the only the multiplication between these two. Okay, that's nothing but here the if I have the A variable 1, then the B is also 1, then only the output is what here the 1. Okay, if I we have the variables as the A as 0, B as 0, it's 0 only multiplication like this. Okay, A is 0, B is 1, then these two, then the it's to be 0, it's to be 1, the 0. Okay, if I have the variables means what here, it's a product form only, it's for doing the multiplication of operations here. One thing you remember this, these two combinations. Okay, if the the variables, both the variables are high, then only the output is high, otherwise it's to be 0. Just you remember one sentence, if I have the both the variables are high, then only the output of the AND gate is high, otherwise it's a low. It's why I'm saying always high or low, then I means what, high means what, 1, low means what, 0. Okay, you should remember. Then if I switch to the next, that's nothing but the or. Okay, or gate, or operations should be represented with the graphical representation as this, like this. Okay, then I have the two variables here, the a and b, and also z is the output. Okay, z as the output. Okay, okay, this is the operations to be represented with the plus operation. This to be this R operations is to be represented with the operator as the plus. Here the plus I am using here. Okay, A plus B. Okay, then the output would be what here, Z. A plus B is to be high. Okay, if any one of the input, okay, if any one of the input is high, then the definitely my output is what, high only. If the both inputs are low, then the output is also low. It means here the what I'm saying here, the just I will be representing these to be have the how many variables here, two variables, so that I would be have the x, sorry, a and B. Okay, then the output is what here, Z. Okay, then these two combinations here can have the only four combinations, either as the 0 0 0 1 1 0 1 1. Yes sir, yes sir, no, yes sir. Then here the plus operation is there. If the both variables are 0, then only the output is what here, the 0, otherwise it is to be 1. If any input is high, why, then the output is what here, the high. That's nothing but the one input is the high, then the output is high. One input is high, then the output is high. Both the inputs are high, then okay. It means here in the AND operations, sorry, our operations are always to be done with the help of what here, the plus operator, and also we will be using the one operator, that the one condition is that if the any one variable is having the high, then definitely the my output is what, high. Okay, in the AND operations, there I will be having the, if the any one input is uh, low, then the definitely output is also low. You should remember either of one. Okay, okay, not operation. Next, I hope you all following this one. Okay, next I would switch to the not operator. Not operations is nothing but the, it's the completely represented with the, okay, one triangle with the followed by the one bubble. Okay, it would be having the only one input, the output is what, only one output. The only the thing is that the my NOT gate is having only one input. You should remember. Okay, you should remember. Many of the students in the even the 7th semester, even 5th sem, just go and ask them. NOT gate is having the how many gate inputs means, if you ask them, they will not tell. Okay, NOT gate is having only one input, that's nothing but the, if I have the 1, then the output is 0. If I 0, then 1. It means what, it's complementing, it's giving the complement of the input. Okay, if I have the 0 is, then the 1. It's 1 here, 0. It's giving the complement of the input. It's giving the complement of the input. Okay, that's nothing but here what I'm saying here, the input of the input of the NOT gate will be having complement of the output of the not gate is input complement of the input. It's means here the I have the, okay, not gates are always represented with the help of the we can say it's the bar, or also we can also say it's a negate. Even also you can say it's a, you can represent with the tilde also. It's nothing but the dash. It's nothing but here the why I'm using the bar always means what, it's sometimes standard reference. Okay, this is the standard reference compared to the this. Okay, so I'll be using the always with the slash only, sorry, bar only, x bar x. Okay, okay, let me have the x bar output is what here, the z here. Z is having the output as the input of the complement, input complement of the input. Okay, so I have the truth table for this one also. Okay, I have the truth table also here. The input is here what here, the x, the output is here the z. Yes sir, yes sir, no. I have the two only one variable, so it's having the only one variable means what, 2 to the power of n. Okay, 2 to the power of n is How many variables are there? That one you have to substitute there. Okay, 2 to the power of n is nothing but 2 raised to 1. It's nothing but the two combinations I will have the only one variable can have the two combinations. That's the x can have the 0 or 1. Okay, as I told you that the not get is having the output as the complement of the input. Okay, its complement means 0 as the 1, 1 becomes the 0. Okay, okay, you should remember these are the main three basic gates. These are the three main basic logic gates. Okay, I am using this. Okay, based upon these basic logic gates we will build the so many other types of logic gates also. We can say them as the derived logic gates. While using these basic gates only, we'll derive the few more logic gates are there. What are those? NAND gate is there, NOR gate is there, XOR gate is there, XNOR gate is there. So many different types of gates we'll be using. Okay, that will be taken to the next coming classes. But you should remember these three are the main basic logic gates. Okay, these three things are the basic logic gates. Okay, you all okay. There is a difference. Okay, the logical operations and also we have the some difference between the some operations algebraic. Okay, the algebraic can be have the plus. Okay, this is all about the basic logic gates. Okay, if I you switch to the next topic as the okay, there might be you getting the confusion. Okay, what is the logic binary, binary logic, and also binary arithmetic. Till now whatever we studied, this one is related to binary logic gates. Okay, okay, this is sometimes I'll be using the binary arithmetics also. Binary arithmetic, what is that one? Okay, if I consider to be uh, for the uh, for the OR gate purpose, I would have the this one is the 1 plus 0 is what here the 1. Yes sir, and also 1 plus 1 is what here the 1 only. But in the arithmetic, binary arithmetic, 1 plus 0 is what here the 1 only. 1 plus 1 is what here the 2. Yes sir. Okay, sometimes I will be using the binary logic, binary arithmetic. Should remember, okay, this confusion. Okay, many of the students get the confusion between the binary. Sometimes I'll be using in the coming classes. Binary logic means what? This combination of the operations. Okay, binary arithmetic means sometimes. Okay, wherever I put the if I have the 1 plus 1 plus 1, this is what here the next answer 3. Yes sir. 3 will be represented with the 1 1. This to be represented what here the 1 0. Yes sir. But here the same thing if I consider as the 1 1 plus 1 plus 1. What is the answer? Only 1. Yes sir. Yes, you are intelligent. Okay. I hope this one at least you should have the this basic idea. Many students they don't have this basic idea also. Okay, coming classes I'll be using the basic binary logic, binary arithmetic. There you should not get the confusion. Okay, that's what I am telling these things in the year only. Okay, take the heading as this. Take some notes also. I will dictate. Okay, some notes. Yeah. Okay, definitions of the. Okay, just to write the first chapter. That is the definition of binary logic. Binary logic. Definition of binary logic. Or we'll give the notes tomorrow. I'll explain tomorrow today. Okay. Okay, I switch to the digital design only now. Okay, digital design is to be used here the completely to the electronics devices. Many of the electronics devices will work with the digital design only. Okay, digital design. Okay, many of the electronics equipments and even electrical equipments are work on the base of the digital. Okay, series light ನೋಡಿದಿರಾ ಟಕ ಟಕ ಅಂತ ಬರ್ತಿರ್ತದಲ್ಲ series light. Okay, whatever the things. Okay, if you want to switch the lights to be the for that is to be based on the digital design only. some combinations, how it is to be done, some parallel combinations, serial combinations, have you know? Okay, you might have studied in the previous classes in the intermediate or in the last year, the first semester or second semester, I don't know. They would have studied the registers in series, okay, registers in parallel. Okay, similarly, I will be using the same concept here, the series, okay, some switches, okay. Here the switches to be considered to be some variables as a variable, okay. The switch to be considered as the one switch is there, okay, yes or no? Okay, there is a one switch, okay. So many switches are there. If I consider the one switch, then the switch can have the only two options, either on off, on or off. Okay, if I taken the 2 to 3 switches, then I would consider to be yes, same as the, if I have the two switches here, the A and switch, B switch. Okay, how many combinations for the switches? Four combinations. If I have the three switches, the switch here, the switch to be considered to be as a variable that can have the two values, either 0 or 1. So I will be switching now the digital design to be completely to the electronics related, okay, electronics related. Okay, where I will be using this complete my digital design means in the electronics devices, in the electrical devices, how to be work with that one. We'll see, okay. Some basic idea, okay, I'll be giving that one. This is in the syllabus, okay, not in the. Okay, switching circuits and also binary signals, how to be working both here. Switching circuits and binary signals. Okay, switching circuits. Okay, okay. The use of the binary variables and the operations are related to binary logic are demonstrated with the help of the some simple logic circuits. Okay, I'll be using here the variables. Okay, switch to be considered to be as the variable. That variable can switch can have the two options as the on or off. Yes, sir. So that I will be considering the one of the switches in the series. Okay, switches in the series. Okay, what I'm explaining is if my series switches are in series, then what would be that? What type of logic gates I am using there? Just I am giving the some basic idea because these things are useful for the next coming classes. Okay, okay. This is my okay. What we have the switches here. Two switches are there. Then the bulb would be glow only when the okay. Then the for bulb glowing purpose I have the one that's the it's what battery cell. It's a cell, okay. If I to be use the two cells in series, then it would be considered as the more than one cell in the series form, then that to be considered as the battery, okay. Okay, this is the positive, okay, this is negative, okay. Okay, my current is going here, okay. Voltage, whatever we have the voltage in the cell, in the battery, that used to be potential voltage, then now will becomes what here the current, okay. If the water is there in the tank, that one we call as what here the voltage. If that water is coming to the in the tap with, through the pipe, that would be considered as what here the current, okay. That's nothing but the whatever the stored in the charges in the battery we call the potential current, potential voltage. That is to be converted to kinetic energy. That's nothing but kinetic, okay. That's to be current, that is we call the current. Okay, that current is flowing in the circuit, okay, through the wire. That the two switches are here, what here the off or on, off, off here, yes, no, off are there, okay. The two switches are here the off, yes sir. Then the my bulb will not glow, bulb will not glow, okay. Switch S1, switch S2, Okay, this means what here, the how many switches are here? I have two switches, so that I will be having the S1, S2 and bulb here. Okay, there then I have my truth table for this particular combinations here, the two variables, truth table I need here. Two variables means what? How many combination I would be having the 2 to the power of 2 is how much? 4. 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. Yes, sir? Yes, no. Okay. Then you have to apply this one. As you already knew, these two are in the series. Both the series, both the switches are on. Then only bulb will glow. Both the switches means what here? The two switches should be one on. That's to be closed. That's to be closed. Then only bulb will glow. Otherwise, it's zero. It means what here? The what type of operations I am using here? The AND operation. If my switches are in the series, then definitely this combination of these two switches in the series, then I can implement this particular circuit with the help of the basic logic gate. What type of logic gate? AND logic gate, AND logic gate here. So that AND logic gate can have the two inputs has this particular operation. Okay, then the operations for this one 0, 0, 0, 0, 0. Then definitely this series switches can be implemented with the binary logic gate, that's to be AND gate, AND gate. Similarly, if I taken the switches in the parallel, okay, this is to be parallel. So I would consider to be I'm sending in the connecting to the where in the one battery here. Okay, battery here. Okay, yes sir, positive negative current is flowing here. Okay, if the any one switch is on, if the either of one switch is on, then the bulb will glow. I have not shown here bulb here, sorry. Okay, bulb here. If my bulb has to be glow means what? Either of one switch has to be on. Okay, that's nothing but here I'm using the what type of logic gate? OR gate. Okay, OR gate. Okay, so the S1, S2, then the bulb. Okay, then the two switches I'm here having S1, S2. Okay, and also bulb is also here. Current is flowing here. This is the battery. Yes, sir? Then I'm putting all together in the combination, sorry, in the truth table. Okay, truth table. Okay, 0, 0, 0, 1, 1, 0, 1, 1. Yes, sir? Okay, my battery, sorry, my bulb has to be glow. Okay, then only one, either of one switch is on. It means here the either of one means what here? Both are here also one. Here is also one. If both the switches are on, then the closed, then on. Then this is 0. There you am using what type of logic gates I can use? Implement here the basic logic gate here, the OR gate. Okay, how I am using the distance design in my real world? It means I am showing here with the help of the some basic things which are related to the electrical, even electrical and electrons. Even you can apply this basic logic gates to the particular in your any of the operations. Okay, any of the operation in the real world entity, you can use this type of basic logic gates to implement the particular problem that has to be solved with the help of what here the basic logic gates. If I have any problem that can be solved, okay, that can be solved or implemented with the help of the basic logic gates. Okay, I hope you all following this. Yes or no? Okay. Okay, even okay. Sometimes I have shown here the completely related to the circuits. Okay, if I have the currents in the some range, okay, I'm sending the some current also. If my current is flowing, okay, my voltage is falling between the two range here, the okay, two range, that is to be 0 to 3. Okay, my voltage, whatever the voltage I am sending here, the voltage that is to be here the 0 to 3 volts. Okay, if I am sending the 0 to 3 volts means what here the, then that's to be fall in the some range. Okay, that's to be some fall in the range. Okay, this is 0, 1, 2, 3. Yes sir? Okay, yes, no? Okay. Okay, this is to be considered as the 0 to 1. This is to be called as the time period. This to be here the voltage. Okay, if my voltage is falling between the 0 to 1, that is to be tolerance considered to be what here the 0 logic. Logic 0, that's to be implemented at the what here the tolerance allowed to be here the this tolerance, whatever the 0 to 1 tolerance will allow the what type of logic? 0. If the my voltage is falling between the 2 to 3, this tolerance to be considered to be tolerance to be considered as the logic 1. Logic 1. It means here the sometimes this is the gap here we have. Okay, while switching from the 0 to 1, 1 to 0, fraction of second is there. That is to be considered as the 1 to 2 voltage. That is to be neglected, neglect. Okay, just to, because my range is my voltage belongs to the 0 to 1 means what here the, that is to be logic considered to be as what here the 0. If the my voltage is belongs to falls under between the 2 to 3 volts means what, that to be considered what here the logic 1. If I, okay, 0 to 3 volts I told you. Okay, if the my I'm sending here whatever I'm sending 3 volts battery here. Okay, 3 volts battery here, but 3 volts battery is completely not utilized in the real time, completely not utilized in the real time. But if I'm not sending the any voltage, okay, if the voltage is falling between the 0 to 3 means here the 0 to 3, you, if I use the uh, uh, 0.7 volts, 0.7 volts. Okay, 0.7 volts means what here the what logic you am I can say here, 0.7 volts means what logic I can use here? 0 logic. Okay, because 0 to 7 is there, 0 to 7, then definitely I would have to say its logic of this one is the logic 0. Then if I am using the 2.5 volts, okay, for the high west way, okay, I can't use the completely 3 volts in real time. I can use only what here the 2.5 volts also, up to 2.5 volts also. Then definitely this 2.5 volts comes under what here the 2 to 3. Then definitely my logic here what here the 1. So the currents, okay, sometimes the voltage is below the 220 volts. We usually will be using the in home and some uh, one to here is what here the tolerance. Okay, this should be tolerance to be to transition tolerance. Okay, this is what is the transition occurs. Okay, transition occurs. This transition, okay, this to be between the these two limits. Okay, if I have that 0 to 1 limit and also 2 to 3 limits, okay, 1 to 2, okay, this is to be considered to be transition is happening here. Either is switching from 0 to 1, 1 to 0. Okay, some logic is switching, you know, that tolerance to be considered as the transition. Okay, transition period, transition period. This to be period is the logic tolerance period for the logic 1. This to be, this period is from 0 to 1, it's the tolerance for the logic 0. This period is between the 1 to 2, it's to be considered as the transition occurs. Okay, transition occurs. This tolerance period, this tolerance to be considered as the transition period. Transition. It has to switch from 0 to 1, 1 to 0. It's to be switching, no? There will be, okay. If the, my voltage is belongs to the I'm using around the 2.5 volts, then I would definitely have to use the logic 1. Okay, sometimes if there are so many industry, okay, they are using the some high level of currents there, even mcb board is there, mcb is there, no, mcb, how the mcb is working there? Okay, if the my voltage is more than that particular input, particular input, then definitely the mcb will be putting the down the switch, putting down switch. That's nothing but here the, it is to be considered to be a working with the help of the logics only. Either to, if the my voltage is more than particular 220 volts, okay, how many voltage you are using in the at your home? Only around 110 volts. 220 volts they will provide for the all the over, okay, all over. But you will be using the only single line. For the industrial purpose they are using the three lines there, for three phase current they are using it. But for home appliances, some home related operations, they will be using what here the only single phase is to be what here the 110 volts. If I am using the more than 110 volts, definitely the MCB switch will be putting down. That's nothing but here the, it is to be organized to be as the logics from 0 to 1, 1 to 0. It's to be switching that particular switch from the high to low because of the high voltage. So the what I'm insisting here, what I'm trying to say here, what here the thing is that here the logic gates can be implemented to the in the real world also. Okay, what you are studying here, that's to be implemented those problems, and also even you can give the particular solution for that problem with the help of the logic gates only. But here the in the examination they will ask the questions directly. Okay, sometimes the VTU is insisting to give the some questions with the real world also. Those real world problems can be solved with the help of the basic gates. Okay, then I'll be giving the some 10 to 10 to 15 questions related to this real world also. Okay, don't worry, I'll be giving in the examination also, internal test also. Those are all not asked in the previous years. For your knowledge purpose, I'm implementing those questions to the giving to the internal examinations. Okay, this is all about the basic logic gates. Okay, okay, if I am using the with the help of the voltage, okay, some signals. Okay, I hope you all using the signals in the medical field. Okay, there I will be using the some displays are there in the medical equipments. There will be using the some signals. Okay, okay, whatever the signal, maybe if it's high, then the definitely to just to switch to the 1. If it's low, then it definitely has to switch to the 0. That is to be how it is to be implemented. Then we'll be seeing that one. Okay, this is all about the help of the how to be implemented with the logic gates to the electronics devices. Now we will see the how to use this logic gates to the particular logic gates to the signals also. If I have the two combinations of signals here, okay, just to tell, this is the on 0, 1, arrow, 1, 2, 3, 4. Yes, sir. This is to be 1 here. This is to be 0, 0 here. Yes, sir. This is the particular operation having the signal as the name. With that signal is named with what here, the one variable, that's the x. If I use the particular name, particular one more signal is here, that is to be shifted with the 1, 1, 2, 3, 4 here. Okay. Here the 0 is here. Don't consider this to be. Okay, 0, 1, 1, 0. I have the two variables here. The okay, first signal name is named with what here, the x. Second signal is named with what here, the y. Okay, there I am using. Okay, how to be implement this to be considered to be AND purpose, OR purpose, and also NOT purpose. How to be used? Okay, if I okay, combination of this x and y is what here, the x dot y is the OR gate purpose, x plus y. This is the input to be for the I will be applying the not not logic gate to the particular signal is what here, the single. Okay, single. Okay, that is to be x to be x bar, x to be x bar. Okay, just I am implementing this one is the x dot y. Okay, this don't consider this 1 0 1 0 combination is what here, the 1 0 combination is for this AND operation is what, 0. Okay, just to move to the okay 1, okay 0. Okay, 1 1 combination would be what here, the 1. Okay, 1 1 it's 0 1 combination is what here, the 0 0 0 combination is 0. This is the signal for the this okay, the both signals are used for the AND operation purpose. Okay, AND basic logic operation, there the I'll be using. Okay, OR operation purpose I'll be using the plus operator here, plus operator here. Just use the operation here. 1 plus 0 is what here, the 1. Okay, 1 1 is what here, the 1 only. 0 1 is also 1. 0 0 is what here, 0. Yes, sir? 0. Yes, no? Okay, if I use the not put to the particular only one input, because the not gate having the how many inputs? Huh? Okay, yeah, okay, we should leave. Okay, you can apply to the any one signal. Okay, one just to consider to be one signal here. Okay, for AND gate purpose, not gate purpose. Okay, not gate is having the input as the x. X is the x bar. Okay, x is having the output as the x bar. That whatever we have the input combination, that is to be complement form 0 to 1, 1 to 0. Okay, this is here the what here the x is what 1. 1 is what here the low. Here is also what here reverse manner. First one, na? This one, na? No, no, no. X is there. Oh, sorry. This one is the. Okay, X is high, 0 is here. Okay. This 1 is there, 1, 0. 1 is there, 0 is here. Okay, 0 is there, 1. 0 is here, 1. 1. Okay. This is all about the basic logic gates. Okay. We are related to, it's related to basic logic gates. Even we can also apply this form here because any variable can have the two options here, either 0 or 1, either 0 or 1. It means here that we are applying the signals to be considered to be binary variable. Okay, variable can have the two transition period, either 0 or 1. If it's for the low level, I have to be considered the logic 0. For high level, I have to be considered, I will be considering it as a logic 1, 0, 1, 0 or 1. Okay, as all of you seen the logic gates with only what here the two inputs, yes, no? Two inputs. Even I can also have the logic gates with the three inputs also. Even I can also have the more than two inputs is nothing but three also, four also, even five also. It means what here the I can also have the three inputs. Similarly, I can apply this one as the AND gate and get earlier we were using what here the only two variables here. I can have the three variables also as the input. Output is what here z. Okay, x, y, z. Okay, I can also have the logic gates. I'll be using sometimes. Okay, in coming classes, logic gate with the three variables. Okay, three inputs. Sometimes students will get confused because logic gates will have the only two inputs. They'll be thinking like that, but here the logic gates can have the three inputs also. Okay, and even the my OR gate can have the more than three inputs also. Okay, 1, 2, 3, 4 also. Okay, a, b, c, d. Okay, this is my output as the z. Okay, it means we are the output here the z will be what here the one term we will getting because of the x y dot z. Okay, then here the z is what here the a plus b plus c plus d. Means what here the we are applying the my logic gates operations. Okay, here the operator is here what here the dot operator for the AND operations, and OR operation purpose I will be using the plus operator here for the output purpose. Okay, the combination of these three inputs will have the only one term, that's nothing but the each and every logic gate will have the one term, that is to be with the two variables, three variables, whatever it may. But the each logic gate will have the how many outputs? Logic gate will have the how many outputs? Only one output. It can have the more than two variables, more than one inputs also. But the output is how many? Only one. Okay, should remember. Okay, so that I have the for one each and every logic gate I have the only one term as the output. Okay. Okay, tomorrow I'll switching. I'll be considering taking the digital logic gates with the some combinations of this one. Okay, derived logic gates also. Okay, a NOR gate, XNOR gate, NAND gate. I'll still be teaching, and also canonical form and also non-canonical forms, and also Boolean functions how to be implemented with the logic gates, even derived logic gates also. We'll be considering. Okay, these are the basic things you should remember, because I will be not teaching these things one more time, just to concentrate on the basic things first. Okay.